Hello students, we will study Kepler's three laws of a planetary motion in this today's lecture. There are three laws of Kepler's laws of a planetary motion. So in this lecture we will start the Kepler's three laws. ठीक है ये सब German scientist Johannes Kepler developed three basic laws of a planetary motion. Kepler's first law statement: when a secondary body rotates around a primary body, it follows an elliptical path. Here, secondary body is a satellite and primary body is a Earth. Let A be the semi-major axis and B be the semi-minor axis. Then eccentricity is given by E is equal to under root of A square minus B square. So, Kepler's second law statement: the orbit of smaller body sweeps out equal area in equal time. That is the orbit of a smaller body, where smaller body is a satellite and it sweeps out equal area in equal time, right? According to Kepler's law, area A1, this area A1 and area A2 sweeps out with respect to time are equal. That is the time covered during T1 to T2 is equal to time covered T3 to T4 is equal to area A1 is equal to A2. This is called as a Kepler's second law. Then next is a Kepler's third law. Kepler's third law statement: the square of period of revolution of secondary body about primary body is equal to the constant multiplied by third power of semi-major axis of a orbital ellipse. Here, from this statement, from this Kepler's third law statement, T square is equal to 4 pi square A cube upon mu, where T is orbital period, A is semi-major axis of orbital ellipse and mu is Kepler's constant. Thus, we have studied these Kepler's three laws. Then in this lecture, we will also study different orbital elements. Here, as shown in this figure, here this is a equatorial plane. This is a inclined plane. This is called as an inclined plane. And in this figure, we have to, from these orbital elements, we have to study different definitions. That is perigee, apogee, line of apsides, then what is ascending node, what is descending node, what is argument of perigee, then what is inclined orbit. All n number of definitions we have to study. If we study these definitions, then we will easily understood the satellite communication. Then first definition, perigee. So what is perigee? Point closest to the earth is called as a perigee. Consider this figure, that is a point closest to the earth is called as a perigee. That is distance from this point to this point is called as a perigee. And perigee distance RP is given by A into bracket 1 minus E, where E is the eccentricity. In terms of radius of earth, perigee height is given by HP is equal to RP minus RE, where RE is the radius of earth. Then next is the apogee. Apogee is a point furthest from the earth. That is a apogee is a point furthest from the earth. That is a longer distance point is called as a apogee. In terms of semi-major axis A and eccentricity E of ellipse, apogee distance is given by RA is equal to A into 1 plus V, where RE is the radius of earth and HA is, that is height, apogee height is given by RA plus RE. Then line of apside. Line joining perigee and apogee is called as a line of apside. Then next definition is a ascending node. So what is the ascending node? I consider again this figure. Ascending node, that is when satellite is moving from, that is south to north, that is a cross section of the equatorial plane, that is this plane, and satellite orbit, that is a cross section or cross section point is when satellite is moving from south to north, then it is called as a ascending node. Then what is descending node? It is a cross section of equatorial plane and inclined plane when satellite is moving from north to south. This point is called as a descending node, and this is called as a ascending node. That is the cross section points. That is the ascending node is a cross section of equatorial plane and satellite orbit when satellite is moving from south to north. And descending node is a point where cross section point, that is a cross section of equatorial plane and inclined plane when satellite is moving from north to south. Then line of episode. Line joining perigee and apogee is called as a line of episode. Line joining to the perigee and apogee called line of episode. Then next is a line of nodes. Line joining ascending and descending node is also called as a line of nodes. Then next, inclination. Angle between orbital plane and equatorial plane is called as a inclination. That is this is a inclination line, that is a angle between inclined plane and equatorial plane is called as an inclination. Then next is the argument of perigee. Angle from ascending node to the perigee is called as the argument of perigee. Angle from ascending node to perigee is called as the argument of perigee. That is the argument of perigee is this. This is the argument of perigee. Then right ascension of ascending node. The angle measured eastward direction in the equatorial plane from imaginary line to ascending node is called as a right ascension of a ascending node, denoted by this ohm symbol. This is a from this figure, that is, this is a right ascension of a ascending node. This is a right ascension of a ascending node. Then next is a true anomaly. Angle between perigee and the satellite position measured at the Earth's center is called as a true anomaly. Then next is a mean anomaly. Average value of angular position is called as mean anomaly, denoted by m. Then there are, to specify the position of satellite at particular instant of a time, 6 elements are required. These are the 6 elements, that is a semi-major axis A, eccentricity E, mean anomaly, argument of perigee W, inclination, that is angle of inclination, and right ascension of a ascending node called as RA. As previously, some of the definition we have studied in previously as we have mentioned. Then next in this lecture we also study look angle determination. It is what is look angle determination? It is basically coordinate of Earth station antenna required for communication with satellite. Basically, elevation and azimuth angle are called as look angles. Elevation and azimuth angles are called as look angles. Consider this figure. Here 3 axes, that is a vertical axis, east axis and north axis forms the coordinate system. And if we join the east axis and north axis, then it will form the local horizontal plane. So this is a local horizontal plane. Then in this we have to define what is azimuth angle and what is the elevation angle. Here consider a position of satellite as shown in this figure. This is a position. Earth station is at the center of coordinate system. This is the Earth station at the center of coordinate system. Local vertical axis, as previously mentioned, east axis, north axis forms the coordinate system. That is east axis, north axis, and this vertical axis form the coordinate system. Join east and north axis to form the local horizontal plane, as previously mentioned. Projection of satellite is measured on the local horizontal plane and line is drawn from Earth station to this point. That is, we have to draw the line from Earth station to this point, and we have to take the projection of satellite. Then here we will define what is azimuth angle. This is azimuth angle basically, but angle made by projected satellite path with respect to north and measured in a clockwise direction is called as azimuth angle. Angle made by projected satellite path with respect to north. This is a projected satellite, and angle made with respect to north is called as the azimuth angle. The next angle is the elevation angle. That is the angle made by a satellite path with respect to local horizontal plane. It is used to determine the height of satellite. Angle made by satellite path with respect to local horizontal plane. This is a local horizontal plane. The angle made by satellite with respect to this local horizontal plane is called as the elevation angle. Okay. In this lecture we have studied the Kepler's laws, and also we have studied different definitions, orbital definitions. Okay.